Marcus buys S shirts for $8 each. He then buys pants, P, for $20 each. What expression would represent the total amount that Marcus spends on shirts and pants? Now, a couple of key things we want to pay attention to. First of all, it says expression. An expression is kind of like an equation, but it simply does not have an equal sign or a value that it ends up being equal to. So we want everything but those. So we'll start with our information. It's going to be $8 each for S shirts. So if I buy one shirt, it's $8. If I buy two shirts, it's $16. We start to realize that, hey, I'm working with a multiple of the quantity of shirts, so that would be expressed as 8S. Well, in addition to paying for shirts, he's also paying for pants. So I'm going to add, because that would be in addition to, pants for $20 each. Well, we see the 20 each again, which is going to be we see the each again, which is going to be an indication that we're multiplying. So 20 times P. There's not anything else we need to do this problem because we don't want an equal sign in it. We simply want it to be an expression, one value in addition to another value. Wilson has built a square with a side length of 5 meters. Cameron built his square by doubling the dimensions Wilson's used. What is the difference in the areas of the two squares? So we know area uses the formula area equals side length squared, or we could say base times height because it is a rectangle. And so area is equal to 5 times 5. So the area is equal to 25. That's Wilson. Let's see what Cameron has done. Cameron built his square by doubling the dimensions Wilson used. So Wilson used a 5. If we double that, it's going to be a 10. So area is equal to 10 times 10. And 10 times 10 is 100, so the area there is equal to 100. Well, the area of one shape was 25. The area of the other shape was 100. Now, why did it get to that value? That has to do with the ratio of the side lengths. Now, we started out with 5 to 10. And so we see that the ratio is being increased by a scale factor of 2. One of the interesting things about scale factor is that when we take that scale factor as it related to one-dimensional values, straight line, and we apply it to area, which is a two-dimensional value, we can square that scale factor and solve a problem like this probably much faster. So the scale factor of the area would be the traditional scale factor squared. So 2 squared is 4. Now when we know that the square factor of the area is 4, let's look back at Wilson's area. Wilson had 25 meters squared. Cameron had 100 meters squared. Well, by what rate or difference do we see? 25 times our scale factor of the area, which was 4, gives us a new area of 100 meters squared. And so there's 2 different ways that we can solve this particular problem. Number 30. Number 30 is a one-step equation. Should be a very quick, very easy problem. We have a coefficient with y, so we want to divide by -6 to isolate the variable. We're going to divide by -6 to the opposite side to continue isolating the variable. And we know that a negative divided by a negative is going to be positive, so y will be equal to 7. Number 31. 4/5 times j is equal to -2. Now, you could certainly treat this as a two-step equation if you want, but we don't have to. Yes, you can say these are being divided from each other and the fraction then is being multiplied to j. Or we can simply treat the fraction as a singular term getting multiplied to j. And so we would want to undo the multiplication that's taking place. And the opposite of multiplying is dividing. And so we could divide by 4/5. Now, when we divide fractions, it's important for us to remember that dividing fractions is the same as multiplying by the reciprocal. So on the left side, we're going to go ahead and show dividing fractions, because when you divide something from itself, it simplifies out. It would be no different than me taking 2 and dividing it by 2, it becomes 1. Or 100 and dividing by 100, it becomes 1. So that leaves us with j all by itself because it has a 1 in front of it. Now on the right side, I'm going to demonstrate multiplying by the reciprocal. Multiplying by the reciprocal basically means I multiply by the same fraction, but I invert the values. In other words, my 5 comes from the denominator up to the numerator. My 4 comes from the numerator down into the denominator. And then we solve just the same way we normally would. -2 times 5 is -10 over 1 times 4 is 4. And we certainly simplify because both are divisible by 2, so that will give us -5 over 2. Last problem. Last problem is again a basic two-step equation. We like to work through our order of operations backwards when we're solving two-step equations. And so we'll look at the problem 6x plus 4 equals -8. Working backwards, we would first subtract 4 from both sides of the equations. 4 minus 4 is going to give us 0, so that will simplify out. 6x is then equal to, well, -8 minus 4, which is -12. And now we can tell that 6 is getting multiplied, so we're still working through our order of operations backwards. 6 is getting multiplied to x, so we want to do its inverse operation, which is division. We're going to divide by 6. To both sides of the equation. 6 divided by 6 is 1, which will leave x by itself. -12 divided by 6 is -2.